All right, so here we go with chapter 13. Here you can see what we're going to start talking about is oscillations about equilibrium. All right, and we'll define, of course, what these things are, what equilibrium is, and everything else like that as we go along. The units we'll cover here are periodic motion, simple harmonic motion, connections between uniform circular motion and simple harmonic motion, one of my favorite ideas. I think that's so cool and fascinating. Period of mass on a spring, and just really what that is in general. The mass on the spring is really what this is all kind of based on. Energy conservation in oscillatory motion. So conservation of energy stuff, so kinetic and potential energy type things. The pendulum, technically the simple pendulum is what we'll be doing here. Damped harmonic oscillations and damped harmonic motion, and then driven oscillations and resonance. Resonance is a very big idea and something you really want to kind of get down to. It's pretty neat. All right, so 13.1, we have really just one page for it, especially since I can't get the other stuff to import. I might try one more time in here in just a second. But we have a couple of definitions here. So this is periodic motion. This is basically any kind of motion that just repeats itself with a period. And the period is the time required for one cycle of motion. All right, so that's just what the period is. So we could think of something like, what's the period of Earth's orbit? Oh, wait, I should do this. I told y'all not. So as y'all just said, the period of Earth's orbit is 365 days or 1 year. Period of Earth's rotation, 1 day or 24 hours. It's just the amount of time it takes to complete one cycle. So this actually is going to have units of time because it is an amount of time. It's just a special amount of time for how long it takes to complete a cycle, which actually you can see down here, this T right there, that is our, that's what we're going to use for period, right? This is period. Okay, that's our symbol for period. It's capital T because it is just a special kind of time. And it even has units of time. The SI units we'd use here is seconds. Okay, next is frequency. And this is the number of oscillations per unit time. All right, so in other words, this is the number of cycles that you go through in 1 unit of time. Works out that this is actually the reciprocal of period. Frequency and period are reciprocal. So we usually use this kind of fancy scripty F for frequency. Okay, just like that. And maybe this would be bigger if I rotated it. Is that better? That would have been smart. Sorry, the last class they were all portrait, not like this. All right, and so you get that. And this is probably something you've heard before. It's usually measured in what we call Hertz. All right, and that is a cycle per second, which you can see down there, Hertz, 1 Hz. That is a Hertz, and it's just 1 over a second. Okay, so period is measured in seconds, it's an amount of time. Frequency is measured in Hertz, which is just a reciprocal of an amount of time. It's a per time thing. So cycles per time or oscillations per unit time. You probably see these things when you look at computers, processors and things like that. It's it's a so many megahertz kind of a thing or something like that. Same thing with radio stations. When you look at the radio station frequencies, it's telling you the frequency of the radio waves that are coming in, and that's what your radio is tuning to, is that frequency. And so how you can see it. And I think those are in megahertz, right? Like whatever they are. I think it's megahertz. All right. Any questions on that? No? Okay. I'm going to try pause here for just a second. The processing speed of a computer refers to the number of binary operations it can perform in 1 second. So it is really a frequency. If the processor of a certain computer operates at 3.7 gigahertz, how much time is required for 1 processing cycle? So I'm going to pause for a second, let you think about this. All right. So this is what we have is that frequency, we're trying to find the period, and how are they related? Yeah, 1 over the frequency is what the period is, right? They are reciprocals of each other. The period is 1 over the frequency is 1 over the period. That means we just have to come here and do 1 over 3.7 times 10 to the 9th Hertz, right? The reciprocal, we can just do the reciprocal of this. What's 1 over 3.7? Just that part. Anybody with a little calculator? 1 over 3.7, what do we get? What is it? No, I don't think it's 2. 0.27. So 0.27, yeah, a little under a third, right? And then 10 to the 9th becomes 10 to the negative 9th, right? And then the reciprocal of Hertz is seconds. And then if we wanted to put this back into actual scientific notation, we can make this 2.7. We essentially multiplied that one by 10, which means we took a 10 away from this other one, which means it should be that, right? Look good? Okay. And even so, you should be able to just at least approximate that, right? So somewhere around 0.3 times 10 to the negative 9th, we got 0.27 times 10 to the negative 9th with a calculator. I do recommend you do both. Try to estimate it in your head and also do it in your calculator. If they're wildly different, then you know you've probably made some sort of math mistake. Either your calculator is lying to you or your estimation is lying to you, and trying to figure out which one it is. Okay? Any questions on that? Any questions on anything else from today? No? All right. Y'all go have a wonderful day.